Welcome to our deep dive. Today we're looking at the unseen heroes of your network: IP address management, DHCP, and DNS.
That's right. They're foundational services. Absolutely essential.
Exactly. They just quietly make sure every device, every user can connect and communicate, mostly without anyone noticing.
It really does feel effortless to the end user, doesn't it? But, well, that's only because of some very diligent work behind the scenes.
Yeah.
So today we'll unpack some best practices for managing these core services. And we'll look at how frameworks like ITIL help and also their role in, security standards like PCI compliance.
Okay. Sounds good. Let's start with IP address management. IPM. It's more than just keeping a list, right?
Oh, much more. It's the whole life cycle. Design, planning, provisioning, monitoring, managing every single IP address you have.
And the goal is basically complete invisibility to the user.
Precisely. And IPM, it kind of breaks down into three main things: inventory, assignment, and name services.
Oh.
For inventory, best practice is really a centralized database. You need that single source of truth.
Instead of spreadsheets everywhere.
Exactly. Spreadsheets just don't scale, and frankly, they're prone to errors. A database gives you a holistic view: IPv4, IPv6, on-prem, cloud, everything.
Right.
And this allows for hierarchical allocation. Think of it like organizing your network logically. It's key for efficient routing.
Makes sense.
Plus, you need regular reconciliation.
Yeah.
Checking that database against what's actually live on the network. That's how you spot issues, maybe rogue devices.
Okay, so you've got the inventory mapped out.
Yeah.
How do devices actually get addresses? That's DHCP, right? Dynamic Host Configuration Protocol.
Spot on. DHCP servers are the ones handing out the IP addresses, usually dynamically.
And best practices there.
Well, definitely centralizing the DHCP server configuration. Consistency is key. You want to avoid conflicting configurations across different servers.
Yeah, that sounds like a nightmare.
It can be, and for security, discriminatory address assignment is really important, meaning you filter who gets an IP, you can use MAT addresses, client types, even user authentication sometimes. It helps block unauthorized devices.
Ah, okay. Like a bouncer for the network.
Sort of, yeah. And don't forget DHCP redundancy, failover, split scopes. You need a plan B if a DHCP server goes down.
Critical. And you mentioned appliances.
Right. Dedicated DHCP appliances can really streamline deployment and often add security and management features.
Okay, so IPM plans, DHCP assigns, then there's DNS, making it all human-friendly, translating names to IPs.
Exactly. Domain name system. The internet's phone book, basically. It works closely with DHCP through dynamic DNS DDMS for automatic updates.
So the name list stays current as IPs change.
Precisely. Key practices here include role-based DNS servers, like separate internal and external servers. That's huge for security and scalability.
Don't want outsiders seeing your internal structure.
Definitely not. And rigorous configuration verification is non-negotiable. One tiny mistake in DNS can cause major outages.
I believe it.
And similar to DHCP, dedicated DNS appliances can offer big benefits in security and management simplicity.
So we have these three core components: IPM, DHCP, DNS, often called DDI. How do they fit into the bigger picture? Like IT operations frameworks. You mentioned ITIL.
Yeah, ITIL, the IT infrastructure library. It provides that structured, service-focused approach. For DDI, ITIL practices are super relevant.
Like?
Well, change control is huge. Any change to an IP pool or a DNS zone, it needs to be properly approved, documented, prevents accidental breakages.
Right. Audit trail.
Exactly. Incident management, too. When something goes wrong, having that accurate IPM inventory is crucial for troubleshooting quickly.
Makes sense.
And capacity and performance management. You need to predict when you might run out of IPs, monitor server loads, keep the services available, and performing well.
Okay, that ties it together operationally. Now, what about security standards? Let's talk PCI DSS, Payment Card Industry Data Security Standard. These DDI services don't handle card data directly, but they're still vital.
Absolutely vital. Think about it. If your DNS is hijacked, or rogue devices get IPs via DHCP, your secure environment is compromised, even if the DDI servers themselves don't store card numbers.
So how does PCI compliance apply here?
Well, PCI demands things like never using vendor-supplied default passwords on any system, including DDI appliances or servers. Basic, but critical.
Still catches people out a bit.
It does. Also, robust access controls, unique user IDs for administrators, detailed logging of who does what, accountability.
Standard security hygiene.
Yes, and importantly, things like malware protection. PCI highlights techniques like DNS firewalls.
How do those work?
They can inspect DNS queries and block requests going to known malicious domains like botnet command and control servers. It's a proactive defense layer.
Cover.
And of course, regular vulnerability scanning and security testing apply to your DDI infrastructure just like any other critical system.
So wrapping this up, what's the big takeaway? Effective IPM, DHCP, DNS. It's more than just plumbing, isn't it?
Oh, absolutely. It's the hidden architecture. It underpins your network stability, it enables your business operations, and it's fundamental to meeting security and compliance needs like PCI.
Right. They're the silent partners keeping everything running smoothly.
Exactly. And integrating them, managing them centrally, applying frameworks like ITIL, securing them properly, that's how you build a resilient, reliable network foundation. It enables innovation, really.
So as networks keep evolving, more cloud, more IoT devices everywhere, maybe the question for everyone listening is, how is the meticulous management of these invisible foundational elements going to shape cybersecurity and innovation next?
That's the question. The complexity isn't going away.